Today is the 15th of January 2024, and this will be our 31st video on some possible questions. Okay, we are looking at some questions from the past paper. Okay, now before I begin, thank you to everyone who have subscribed to our channel. I appreciate it a lot. Okay, please, if you haven't already, can you consider subscribing, following? If you get the video, please share, please like, leave us some nice comments. I will appreciate that. Okay, tell us how the video is helping you and your friends. Okay, especially those of you who are going to write exams in a few months. I would like to hear how it's helping you. Okay, and it's good for me as well. I can improve. Okay, and I can bring in questions and maybe see how best I can relate it to you so that you can understand. Okay, in the comment section you normally see please follow my notes / scripts. Okay, it's very important because this is maths. Okay, so for instance, this is y is proportional to x. So if you hear anything like y is proportional to x squared, please go by the notes. Beware of scammers. Okay, they will send you an email. They are trying everything. Just beware. Okay, if you've not heard me say it, it's not coming from me, and I won't come into your inbox asking you to donate money to charity or something and giving you foreign numbers to put in money. No, if I want to say it, I'll say it on the video to everyone. Okay, so please beware of scammers. Recap, please watch last video for recap. We've been looking at some interesting questions. Some of them, like the one we have today, I'll use them and I explain further for you to understand, so that if it comes in one form, you can answer. If it comes in another form, you can answer. Now, starter. We did a question in our last video about proportionality, so I thought I'll bring a starter in. We've done videos on that. Please go back and look for it. It's there, but I thought I'll use as starter or our mental math section to just remind you a bit. So y is directly proportional to x. What that means is, as y is increasing, s is increasing, or as y is decreasing, s is decreasing. Okay, so in real life, it can be like you went to the shop. The more you pick, the more you spend. The less you pick, the less you spend. Okay, that will be a direct proportional instance. Okay, the more you drive, the more fuel or mileage you do. That is also a direct proportional instance. Another thing is Yeah, so these are some of the things you can look at in real life. Okay, if you have a bag of rice, the more you cook it, the uh the less it becomes. That is inverse. The more you cook, it's reducing. Okay, that will be an inverse directional. One variable is increasing, so more cooking. The other one is decreasing, less rice. Okay, so that's so y is directly proportional to x means when y is increasing, s is increasing. This is how you write it. That is a proportionality sign. Okay, but if you want to solve a question, assuming it came in a question, then you are going to add a constant and bring an equal to. So y equals kx. So you can find the constant if you know y and x, and then you put the constant back into this equation, and then if you are given y, you can find x. Okay, y is, so that was what we did in the past paper question, in the video that we did. Okay, so you can go and find it. It's just like the video we did recently. Y is directly proportional to x squared. So as y is increasing, s squared is increasing. So if I introduce a constant, it becomes y equals kx squared. I think I've discussed this in one of the status. Okay, so here you can put in the constant. If you know the value of y, you can find s squared, or if you know the value of x, you can find y. Okay, now y is inversely proportional to x. So the example I gave, you have a bag of rice. The more you cook, the less rice you have. Or bag of potatoes, the more you cook your potatoes, the less it becomes. Okay, so one variable is increasing, more cooking, but you're having less. So in a week's time, you might have to go back for more. Now, with this, if you bring the equal to sign and you introduce the constant, your equation becomes y equals kx. Okay, they can also give you y is proportional, inversely proportional to x squared. So it becomes y is proportional to 1 over x squared. Okay, so y equals kx squared. And immediately you do that, you can find the constants depending on the y and the x value. And then you put the constant back into the equation, and then assuming you are given either y or x, you can find one of the values. Okay, so we saw that in one of the videos recently. Now there's another one which I guess explain y is proportional to 1x squared. So when you put in the constant, you have y equal to kx squared. Okay, now today's example. Solve the simultaneous equation y minus x equals 2 and y equals 2x squared plus 5x plus 1. Here they said solve. Okay, we've seen questions where they've given us two equations, simultaneous equations, and they've asked us to plot it on the graph. So because they've asked us to solve, okay, I guess lifted it out of the paper. It's a, a calculation paper, and it's a higher paper as well. Okay, so I'm just, and then they said leave your answer to 1 decimal place. So what I am doing here is I'm going to solve it simultaneously, and I'm also going to plot it on the graph, which you haven't been asked to do. Okay, there are questions where they'll give you, but if you look at the x here, x is the power 1, so this is a linear, this is this one here, y minus x equals 2 will be a straight line. Y equals 2x squared plus 5x plus 1 will give us a curve open upwards because the x squared is positive. You are supposed to leave your answer to 1 decimal place. Now I'm going to solve, and then I'm going to plot these two on the curve. Okay, because they've not asked me to plot, I had to use my own x intervals, and I'll show you what I did just for explanation reason. So y minus x equals 2. So it implies y equals 2x plus x. Okay, that will be for the first equation. Now we already have another equation, second equation, which is the quadratic equation for y. So now that I've made y the subject from the first equation, I can equate both. So I have y equals 2x, 2 plus x, my first equation, and y equals 2x squared plus 5x plus 1, my second equation. So I'm going to equate 1 is to 2 because both of them are equal to y. So I have 2x, 2 plus x equals 2x squared plus 5x plus 1. So I'm going to solve for x. Now I'm going to take 2 to this side. This is plus 2, so if it comes to this side, it will become minus. This is plus x, so if it goes to this side, it will also become minus. So now I have 2x squared, my x minus 5x. Okay, 5x minus x will be 4x. Okay, now 1 minus 2 will give me minus 1. That will be our third equation. Now this equation that we've got, I'm going to apply the quadratic equation, okay, to solve it. So I have ax squared plus bx plus c equals 0. A is never equal to 0, because if a is 0, then the x squared is gone. So it is no longer a quadratic equation. It becomes a linear equation. Okay, so this formula here, x equals minus b plus or minus b squared minus 4ac over 2a, only applies to quadratic equations. Okay, now the quadratic equation we have that we solved when we equated the equation 1 and equation 2 was 2x squared plus 4x squared minus 1. Okay, that was what we got here. Okay, so that's what we want to find the values of x for. Now if you compare, a will be 2, b will be 4, and c will be -1. So we are going to use a, b, and c, substitute into this equation, find the values of x. Okay, now minus b will be -4 plus or minus the square root of minus b, which is 4 squared, minus 4. Okay, a is 2 and c is -1. We have all the information here. I've written it out. So x equals -4 plus or minus 16. Now minus becomes plus. 4 times 2 is 8 times 1 is 8. So -4 plus or minus 16 plus 8, which will give us x equals -4 plus or minus the square root of 24 all over 4. Now the square root of 24, remember, is a calculator paper. Okay, so the square root of 24 is 4.9 if you do it correctly. Okay, because the square root of 25 is 5, so 4.9 is about right. Remember, we did a video on estimation. So -4 plus or minus 4.9 divided by 4. So if we want to look at the numerator, we are going to get -4 plus 4.9 over 4, or -4 minus 4.9 over 4, -4 plus 4.9 over 4, or -4 minus 4.9 over 4. Okay, because it's plus or minus. Now 0.9 divided by 4 will give us 0.2. Okay, that is positive, because -4 plus 4.9 will give us 0.9 divided by 4. So if we round it to one decimal place, we'll get approximately 0.2. -4 minus 4.8 will give us -8.9 divided by 4. That one also, if we run it approximately, we'll get -2.2. Okay, so the x values are 0.2 here, or -2.2. The question says we should leave it to one decimal place. Now you haven't finished, because that is just the x's. Okay, so you are going to find y. Now if you look at the equation you've been given, okay, that is the first one and that is the second one. Okay, the first one, y minus x equals 2. We said y equals 2 plus x from the beginning. That's why we could equate the two y's. Now because this is a linear, this is simpler than that, so I'm going to put my s value in the simple equation, which is y equals 2 plus x. So the first one is, when x is 0.2, y will be 2 plus 0.2, which will be 2.2. So x equals 0.2, y equals 2.2. That is the first solution. When x is minus 2.2, okay, y equals 2 minus 2.2, which is minus 0.2. So the second solution is minus 2.2, y is minus 0.2. So you finished. Okay, that is the question you've been given there. But I wanted to go further and explain. Okay, so this is solving it algebraically. Now, assuming you've been given these two questions again, and they've asked you to solve it graphically, so that's the part I'm going to do. Because they didn't give me the intervals, I chose my own intervals because that wasn't part of the question. So I chose the interval for x from minus 3 to 3. So on my graph, on the x-axis, I'm going to do the intervals minus 3 to 3. Okay. Now, so on the table, my x values is from minus 3 to 3. You remember they gave us a question like this before, where they gave us the intervals and gave us some of the values of y. Okay, so we didn't have to do all. But this one, I wasn't asked to do that. I just wanted to show you, okay, how it's the same thing on solving it by algebra and solving it by graph. Now again, this is linear because it's x to the power 1. Okay, so now x is minus 3 to 3. I choose my own interval. Okay, now, so, and then plus 2 plus x. So I have 2 for all of them. Okay, you can see. So y, okay, so when x is minus 3, 2 plus minus 3 is minus 1. 2 plus minus 2 is 0. 2 plus minus 1 is 1. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. So I've come here and I've written the coordinates out. When x is minus 3, y is minus 1. So when x is minus 3, y is minus 1. From the table I've created. Okay, you can use the other method, just solve it out. Okay, now when x is minus 2, y is 0. When x is minus 1, y is 1. When x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 4. And when x is 3, y is 5. Okay, so I've written the coordinate out here. Okay, now I go on with the second equation to find the values of x and y in the same interval minus 3 to 3. So I've written x in the interval minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now the equation says 2x squared. So first of all, I'm going to find x squared. So x squared for minus 3 is 9. Minus 2 is 4. Minus 1 is 1. 0 is 0, 1 is 1, 2 is 4, 3 is 9. So now 2x squared in this equation is 2 times the 2x squared I've just done. So 2 times 9 is 18. 2 times 4 is 8. 2 times 2 is 2. 2 times 0 is 0. 2 times 2 is 2. 2 times 4 is 8. 2 times 9 is 18. Okay, so we've done the 2x squared. Now the second one is 5x. So our x again. So 5x. So 2 times 5 times minus 3 is minus 15. 5 times minus 2 is minus 10. 5 times minus 1 is minus 5. 5 times 0 is 0. 5 times 5 is 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Now the last part of the quadratic equation is plus 1. So I'm going to replace plus 1 for all the values of x. So now I have 2x squared, I have 5x, and I have 1. So whatever values I get, I'm just going to add. 18 plus minus 15 will be 3, plus 1 is 4. 8 plus minus 10 is minus 2, plus 1 is minus 1. 2 plus minus 5 is minus 3, plus 1 is minus 2. 0 plus 0 plus 1 is 1. 2 plus 5 plus 1 is 8. 8 plus 10 plus 1 is 19. 18 plus 15 plus 1 is 34. So now I know when x is minus 3, y is 4. So that's this coordinate. When x is minus 2, y is minus 1, the second coordinate. When x is minus 1, y is minus 2, the third coordinate. When x is 0, y is 1, there. When x is 1, y is 8, there. When x is 2, y is 19, there. And when x is 3, y is 34, there. Okay. So now, what am I going to do? I'm going to plot them. The first table, I have the coordinates here, and I'm expecting a straight line. The second table, these are my coordinates, and I'm expecting a curve opened upwards. Okay, so when I plotted it, this is my line here, y equals x, y minus x equals 2. Now on the x-axis, I gave myself an interval minus 3, minus 2, 1, 0, 1, 2, and 3. Because that's what I use on my table. But if you look at the table for the second one, y goes as high as 34. Okay, so because of that, to get my curve and get an accurate thing, I did y from minus 6, okay, all the way up to 34 plus 34. Now equal intervals of 2, so 32, 33, 34. So from 0 here for the y-axis 2, okay, 4, 6, all the way to 34. And then I did it for the negative as well. I labeled my y, labeled my x. My title was a graph of y minus x equals to, and y equals 2x plus 1 in the intervals of x minus 3 to 3. Okay, so now I have my coordinates, so I guess I have to plot. Okay, so if I plot the x's, these coordinates here, on the graph, I get a linear graph all the way straight here. Okay, now if I plot the coordinate for the quadratic curve, which I know should open upwards with these coordinates, okay, you can pause and do your own plotting. If you are going to write an essay in few months, it's good you do it so that you are confident with the graph. Okay, so when I plot all the points, I get a curve. Now where the curve cuts the straight line is my solution. Okay, so if you can see here, the first intersection is when x this on this line is minus 2.2 and the y is minus 0.2, which we solved earlier on. Okay, now the second one is, it cuts again when x is 0.2, y is 2.2. Okay, so if you draw it, if assuming you were asked to draw it graphically and find the values of x and y, these are the points you are going to go for, which I have drawn here. But here I did that for explanation, to explain further to you that questions like this you can be asked to solve, or you can be asked to use the graph method to find your answer, where you need to look for the point where they intersect. So assuming it was two curves, they have to go for the point of intersection for the two curves. But this is a straight line and that is a curve. Okay, so now we found the solution graphically, which we're not supposed to do with the quick method. So that gets proved that we have done the question, the solution right, using the algebra method, which we got earlier here. Okay, so when x is 0.2, y equals 2.2. That was one of the points. That was this point here. This one here. And then when x is minus 2.2, y is equal to minus 0.2, which is this point here. Okay, here again I gave my graph a title. I've labeled the y-axis and the x-axis. I started from the origin. My date is just for my reference, so that assuming I need to check my notes, then I know that this graph is part of what I did, the question I solved on this date. Okay, but assuming I had to write, I could write it in pen here because it's not part of the graph, but assuming I was writing it here, I had to write it in pencil. Okay, everything of mine is in pencil. My scale by eye judgment is accurate, equal intervals, as you can see. Okay, I went as far as 34 because the table for the quadratic graph is gave me a coordinate up to 34 for the intervals of -3 to +3. Okay, so that's what I wanted to show you today. Please subscribe, share, don't get pity yourself, especially if you know somebody who is writing their exam in a few months. Okay, help your friends, push yourselves so that you'll be able to get the grades that you can get. Thank you so much for watching our video today, and I'll see you in the next.